Okay, in this next example, we're told that a line segment EF, okay, the line segment is EF. It has an endpoint E, which is at 2 1/8 and negative 3 1/4, which we'll graph in a minute. And then they tell you that the midpoint is half and negative 1 1/2. We know one endpoint, which is E, and we know the midpoint. What do we need to find? The other endpoint. Okay, the line is EF. So we actually don't know F, but we know halfway from E to F, right? We know the midpoint. So let's start. We know that E is located at 2. So here's 2 and 1/8. Where's 2 and 1/8? Just a little bit above 2. That's the X value. And then negative 3. So we're going to go down 3 and 1/4. So negative 3 1/4. This is where the point is approximately. Oops. Wait. Sorry. Around here. Okay? Okay. Have that point plotted. We know the midpoint is at half. Well, where's half? We're counting by 1. So I start at 0, halfway to the right, and then down negative 1 1/2 is right here. Okay, this is the midpoint. Okay, I'm going to draw a line here. The line segment is EF. I know E to the midpoint, so I'm either going to extend the line going which way? This way, not that much, or this way, right? Oh, no, sorry, not that way. It only can be extended this way because this here is the midpoint, right? It's halfway between E and F. Well, I need to figure out where is this F coordinate located exactly. We know that a midpoint is located directly in the middle of a line segment, right? So we can actually find the slope. Do you remember slope? Rise over run from E to M. Because the slope from E to M, so the slope of EM will be equal to the slope of what? MF. They have to have an equal slope because they're the same distance apart from the midpoint. Okay, so how do you find the slope of a line given 2 coordinates? We don't even need to use the graph. Let's use the points given. We have our M and we have our E. How do you find slope of a line? Yes. Y2 minus Y1 over X2 minus X1. I have X and Y. Does it matter which one I call 1 and 2? No. Well, if I call this 1, that has to be 1. Let's call this 2. And I'm going to flip the page so it's not as messy. The slope of any line segment, I need to take the Y values and subtract them. So Y2 minus, what's Y1? What's the value of Y1? It's a negative. I'm subtracting a negative, right? Over, what's X? Half minus 2 and 1/8. Okay, I want you to simplify this. How do you rewrite 1 1/2 as an improper fraction?
3 over 2.
1 times 2 is plus 1. So it's negative 3 over 2 because it's a negative fraction. What do you do when you're subtracting a negative? 3 times 4 plus 1, 13 over 4. Divided by half minus, what's 2 times 8? Plus 1, 17 over 8. Good. Let's simplify the numerator. What do you need when you're subtracting or adding fractions? What do you have to do with the denominators? Yes? So what's a common denominator for negative 3 over 2 and 13 over 4? So we need to multiply this by 2. Okay? And we have, I'm just going to write it over here, negative 6 over 4 plus 13 over 4 over, common denominator for this, 8, good, 1 times 4, 4 over 8 minus 17 over 8. Now you can simplify. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus 17 over 8. 3 over 2 minus 1 over 8 minus Okay, I'm just putting the equal sign here because I don't have space. What's negative 6 plus 3?
13.
Positive or negative? Sorry, negative 6 plus 13, sorry. 7 over 4 over, what's 4 take away 17? Negative 13 over 8. So right now we have our slope. So we have slope is equal to 7 over 4 over negative 13 over 8. What does slope represent on a graph? Rise over run. Okay, so I know the rise. So back to our graph, I'm just going to draw it here. This was E. We know the rise from E to M is 7 over 4. And we know the run from E to N was negative 13 over 8. Well, think about it. It's rising positive, and the run is negative, right? Because it's moving to the left. I need to know where this line segment ends. I need to know F. Well, the slope from E to M, is it the same as the slope from M to F?
Yes.
M is directly in the center, so it's an equal distance from both points. So I know that from M to F, it has to rise by what? 7 over 4. And then from M to F, it has to run negative 13 over 8. Well, what was our M point? What was M? Where was M located? Go back to your notes. Half and negative 1.5. Which part of this coordinate represents the rise and which part represents the... which part would you show an increase in the rise and which one would show an increase in the run? Well, how do you read a coordinate? X, Y, right? Is the rise X or Y?
Y.
Y. Is the run X or Y? So I know that from negative 1.5, we have to rise 7 over 4, right? And then from half, we have to run negative 13 over 8 in order to get to the end point. So let's rewrite this part and this part to figure out the new coordinate. So the rise, the new y coordinate is located at 13 over 4. And where's the new x coordinate located? Okay, we forgot to include the negative. It's not 13 over 4. It's 1 over 4. And the new x coordinate is located at negative 9 over 8, which, let's simplify that, is negative 1 and 1/8. Therefore, f is located at negative 1 and 1/8 and 1 over 4. This is my new x and my new y. And we can look back at the graph. Okay, look here at the graph. It was negative 1 and 1/8. Okay, somewhere over here. Mr. Miller is going to show you an easier way. I'm going to upload this and he'll...
Made with Doodlecast Pro.